our probability unit. Now, at the start here, before we get into all the probability and how to calculate it, we're going to look at where the information comes from. And how we go about getting that information is going to base what type of term that we use to describe what we're doing. So for instance, surveys, you've taken lots of them around here for different things, where you're trying to get information, but you're just asking people their opinion for something. You're just saying, do you like this or this better? Or what's your favorite color? Whatever it happens to be. And that's fine to do, except you want to make sure you're allowing people to have their own thought about it. If the design of your survey favors a certain outcome, like let's say, for instance, hi, would you like to try this energy drink or this one that tastes great and makes you go faster? Wonder if you're trying to sway me a little bit. That's what we're talking about with bias. You're trying to make me think your way. Observational study. Here, the key word is observed, and there's no attempt to influence. I may know in my head what I'm watching for, but you're never going to know it because I'm just kind of sitting back and watching. An observational study might be maybe before our next test. I'm just sort of walking around, watching who's working on the review in class and then not, just kind of doing a study, and then I'm going to see how they do on the test. That would be an example of an observational study. And again, we've got an example here, and there's going to be no bias, no influence. I'm just watching them, so I can't really be biased in a study. However, and these two are really close together, an experiment, we're intentionally doing something to people. So I'm going to make these people do something and then see how they react. So I'm trying to influence and kind of see what the results are going to be. So for instance, you may have two groups of people that have an illness or something. You give one of them a new treatment, but the other one you give a placebo, which is like a fake pill, or it could be called a sugar pill or something. Make them think they're doing something, but they're not really. So, and then if the only way really to have bias here, if the participants know which group they're in, they're going to have a bias. Like if they're not getting the treatment, maybe they'll be like, oh, I'm sick, even though if they really don't feel that way. So when we're doing these, when we're trying to figure out what it is, for instance, here we're going to see if it's an experiment or an observational study, since they're the closest together. We're going to identify the control group, the group that doesn't change, and the treatment group, the group where there is a change being made. So if it's an experiment, we're also going to determine whether there's bias or not in that based on how it's written. So here's our first situation. Find 20 adult ducks, half of which are domesticated, again, kind of taught how to be around humans, and compare their weights. Observational study, because we're just watching them, it's not like we took half of them out of the wild and started doing something to them. But the domesticated ducks would be the treated group because they have a different experience than ducks that are just out in the wild. And the wild ducks would be my control group. But again, observational studies can't be biased anyway. You're just watching to see what happens. So that's kind of how we're going to tell the difference. I want to know how students and parents feel about school uniforms. That'd be a survey. I ask random people, what do you think about this? Maybe I ask you guys. Maybe I ask my 4th hour, my 8th hour. And I can just see what their opinion is. That's a big thing about surveys. Surveys get based typically on opinion. What do you think? How do you feel about a certain thing? And what's going on with it? Finally, we get to something you guys get to be involved with here. So state whether each of the two following situations are an experiment or an observational study. Identify the control and the treatment group, and if it's an experiment, determine if there's bias. So we have 300 students and randomly split them into two groups. One group is going to practice basketball 3 times per week, and the other group doesn't practice at all. After 3 months, you interview the students to find out how they feel about school. Okay. So we got 300 students in 2 groups. One gets to play basketball, one doesn't. Experiment or study? Experiment. I agree. And it's an experiment because We are splitting them. It's not like we just watched them and some of them happened to and some didn't. If we're physically doing groups, physically making them be in groups, that's going to be an experiment. So here then, what would be our treatment group? Which group is there a change being made in? Yeah, the one that practices basketball would be my treatment, because maybe they wouldn't normally play basketball 3 times a week. Maybe they wouldn't do it at all. I don't know. And then my group I didn't change would be my control group, because we're going to see how they feel about school versus how this group that plays basketball does. So we've got an experiment. We've got our treatment, our control. Is there bias with this? You're just going to ask them how they feel about school. Not really. Now, if you got there and started asking what they thought about basketball or what they thought about something else, maybe. But just ask them in general what they think about school. You're not really telling them, see, you're playing basketball, you're going to like school a lot better, to try and get them to sway them. You'll see some examples here a little later that are really obvious and when the bias starts to come in. All right, 100 students. Half participated on the school math team and compared their GPAs. Did I make people join the math team? No, they participated, but I didn't split them into a group and say you're going to. So that's going to be an observational study. Now here's the part that can get interesting about our treatment versus our control group. On the math team, they're the ones that are different from the rest of the group, so that's the treatment. The control group isn't even mentioned in the problem. My control group would be my non-math people. So sometimes you may even get to a point that your control group isn't going to be mentioned in the problem. We're just going to assume that we know that's going to be my other group. And again, with an observational study, you're not going to have bias anyway because you're just watching them. So that's how that's going to work between experiment and observational study in my survey. Now, I don't know. For some of you, this next part may be something that's familiar. You may have gotten to deal with some of this in geometry class in another format. Correlation and causation. Correlation, when one event happens, the other is more likely. Not always going to happen, but likely. When the pond is frozen, it's more likely to snow. Well, if it's cold enough for the pond to be frozen, when moisture comes down, it's typically going to be snow. That kind of happens, but it doesn't necessarily mean that it's going to happen every time. Causation, one event is the direct cause of the other. You turn on the light, it makes the room brighter. You turn off the light, it makes the room darker. Okay, one thing directly causes the other. But again, you've got to kind of keep your own bias out of this at times. For instance, for one example, children who live in very large houses usually get larger allowances than children who live in small ones. Sometimes. Okay? But it doesn't mean necessarily if you live in a huge house, you're going to get a huge allowance. It could be the amount of money your parents have. It could be someone else giving you money. You don't know. So that would be a correlation where it could be true, but it might not necessarily. That's the key here question. Is it likely or is it definitely going to happen? All right. So with these guys, determine if it's a correlation or causation and try to do a brief explanation of why. If I jog in the rain, I will get sick. Correlation. Because I may not get sick. I may go out in the rain and jog all the time, never get sick. Somebody else may go out, one drop of rain's out there, they get sick. It's just, It could happen, but not necessarily. Studies have shown that eating more fish will improve your math grade. Correlation. Now see, if they just said brownies instead, I'd have had to have said causation. But correlation. Because again, I mean, and you can use any example you want. Here's the one I just kind of thought of. Vegetarians can be good mathematicians. Or maybe some of you say, I'm a good mathematician, I don't like fish, never eat it. But just something to explain that there's some other thing that could cause you to either improve your math grade or somebody else could be good at it with something else. If I lose a library book, I pay a fine. Causation. Hopefully they're not going to fine me if I have just returned it on time. Causation. Lose book. Lose money. Because why am I paying the fine? Because I lost the library book. If this happens because of this, that's when we're in causation mode. But only when it happens that way each time. Reading a diet book will make you lose weight. Probably not. Maybe follow what the book says. That could help. But just reading it, probably not so much. If I miss a day of school, I will not earn the perfect attendance award. Causation, because the whole idea of perfect attendance is you don't miss school. Missing does not equal perfect. Again, we're just trying to keep it simple. And finally, owning an expensive car will earn me lots of money. Definitely correlation. A lot of times it'll mean I have less money because I spent it all on the car. Work could earn me money. But it's just looking to see where things come from, and the where and why part is kind of what that whole section's going to be about, and how it's going to affect some of these numbers that we're going to come up with. But it's also a lead-in, and it was a good enough one that I wanted to put these two lessons together. So again, we're going to be putting this book part, which is basically just saying which type it is, with the study. Now, we're not going to read through this word for word and everything. It would drive some of you crazy. So basically, here's what we're going to do. I'm going to hit some highlights of some things. We're going to go through the examples together, because I want to make sure that we have an understanding of things. But if you want to go back later, there's some things in here you probably want to go back and reread. But like I said, me reading to you verbatim would take time and effort and probably put you to sleep. So here's our key terminology back here. When we're looking at these, okay, here's our survey showing up again. And again, it's responses regarding opinions. That's the true example of a survey, just to kind of generalize it from before. Experiments, again, have an experimental group, or a test group maybe it'll be called sometimes, and a control group that doesn't change. And there's really good examples right next to it on what those each would be. And then again, our observational study, observing without being affected by what's going on. They're just kind of going along doing their thing and see how they react to it. And that's basically all it is. It's just kind of seeing how those things work. So how do we, again, tell some of these differences? Well, we're going to expand what we did in that first one a little bit. What we're going to do now as we get over to the back of this is not only are we going to try and determine between survey, experiment, and observational study, we're also going to try to figure out a population where it could be selected, where we could actually do this. So for instance, on this first one, scientists studied the behavior of one group of dogs given a new heartworm treatment and another group of dogs given a false treatment or a placebo. Would that be a survey, an experiment, or an observational study? An experiment. Because one were given this treatment and one were not. The ones that are given the treatment, of course, is my treatment group. The word kind of makes it obvious. And the ones given the false treatment or the placebo, which basically means they're being given nothing, is the control group. Where might I be able to locate this particular population? Where do you think something like this would be done? Yeah, maybe at like a vet office. So again, we're just trying to figure out where it could happen, how it can happen, and how the different parts would be affected. So, all right. Next one, we got ourselves some yearbooks. The yearbook committee conducts a study to determine whether students would prefer to have a print yearbook or both print and digital yearbooks. What do you think? Which of the three? I agree, because here we're not just observing people, we're actually asking them something. So here, okay, so let's see. So surveys, we don't have the two different types of groups here, but where would I find my sample group? Yeah, so maybe, I don't know, you could have a school, or you could be more specific, you could ask some classes what they think. But again, the determination here of why it would be a survey is that you're asking for an opinion. It's not necessarily factual, you just want to know what people feel about something. That goes away from our experimentation type idea. So again, just kind of getting us thinking a little bit. All right, a couple more different ones. We're going to start getting into some odd ones here. Research company wants to study smokers and non-smokers to determine whether 10 years of smoking affects lung capacity. This one I'm always curious on because I get two different arguments. And those are the two I always get. Okay, so I've got myself an observation and an experiment. Anybody care to try and argue theirs? Right, the big thing here is they're just studying them. It's not like we're saying, you all need to smoke for the next 10 years and you need to not. Yes, so we're just kind of watching them. Yeah, I'd definitely go with the observational study here. Because again, you've got your two groups. You've got your smokers. You've got your non-smokers. So you get to see your treatment and your control groups. So that's all you would look to see here. You'd see how the smoking affects that particular participant. You're going to observe that. A national pet chain wants to know whether customers would pay a small annual fee to participate in a rewards program. They randomly select 200 customers and send them questionnaires. Survey. Because again, they want an opinion. Would you pay the small fee or would you not? And basically they're going to use that to figure out what they want to do. This is the favorite part of mine on this whole lesson coming up here. Trying to figure out, when you're actually designing your study, if you're going to have one, trying to make it as precise as you can, okay? You don't want stuff that's wordy. You want to avoid it cause a strong reaction. You will think after doing this. You don't want to tell someone how they're going to think or how they should respond. And definitely don't address more than one issue within one question because it can really confuse people. So, for instance, if you are asked a survey question, don't you agree that the cafeteria should serve healthier food? That's kind of biased because it's telling you that they don't serve healthy food already before you even have answered the question yourself. So you might want to get rid of, what do you think of the food the cafeteria should serve? And leave it at that. Okay. How often do you exercise? That's okay. That's unbiased because it's just asking for factual information. It's not saying you should exercise more, right? Or something like that. So down here, how many glasses of water do you drink a day? That's not biased. It's just it wants some information. I'm trying to figure something out. Do you prefer watching exciting action movies or boring documentaries? Biased, exciting, boring. Avoid those words that could sway somebody one way or the other. So then once we make sure that we've got a study, that we're not asking questions that are going to sway somebody, and we actually get to design it, we're going to try and come up with an objective. Okay, what are we trying to find out? Who the population is, and then come up with some questions. So here, we're looking for online courses. He wants to conduct a survey to determine how many students at his school would be interested in taking an online course from home. State the objective of the survey, suggest a population, and write 2 unbiased survey questions. Okay? Objective, find out students' interest in taking an online course from home. Population, student body of the school. Makes sense. Questions, do you have internet access at home? That'd be kind of important if you wanted to take an online class. If offered, would you take one? Okay, not, do you think online courses are dumb? Would you quit coming to school? Things like that. So, in his follow-up article, Jim conducted a survey to determine how many teachers from his school with at least 5 years of experience would be interested in teaching an online course. State the objective, suggest a population, and write 2 unbiased survey questions. Okay, what's Jim's objective here? Right. Interest in 5+ year teachers teaching online class or something like that. And I guess that objective kind of names off our population pretty straight, doesn't it? All 5+ year teachers, because you want to see how many you actually get here. This will be the part that's interesting. What type of a question could I ask? If you wanted to find out if these teachers were interested in teaching an online class, what could you ask? Would you be interested in teaching an online class? Okay. That's straight into the point. So now we've gotten that one out of the way. What might be one more we could ask? Okay, now that's a good one. What's the other one?
Have you ever taught an online class before?
Okay, we could say, have you taught online before? And you actually could, Noah had mentioned you could ask like a follow-up question and say like, if not, asking for my first question, Why so? If you're not interested in teaching online, why is that? I don't have internet access at home. That'd be a good reason. And you could kind of do some follow-ups that way to kind of see how that would work. Last thing. See, no numbers anywhere. All right, identifying flaws. That can be hard in ourselves, much less in the experiments that we design. So last experiment here. An electronics company wants to test whether using a new graphing calculator increases students' test scores. A random sample is taken. Calculus students in the experimental group are given the new calculator to use, and Algebra 2 students in the control group are asked to use their own calculator. When given the same test, the experimental group scored higher than the control group. The company concludes that use of this calculator increases test scores. What's the problem here? Yeah, we're giving the higher level students the better technology and the exact same test and then wondering why they score better. Well, because they scored better probably with just their brains. So that's how this works. So, and like this said, the flaw can be corrected by getting a sampling of both types of students and kind of seeing what the difference is. Or even doing two separate studies, one with Algebra 2 and one with Calculus would be a good idea. So our practice, all right. Research firm tests the effectiveness of a de-icer on car locks. They use a random sample of drivers in California and Minnesota for the control and experimental groups. They conclude that the de-icer is effective. What's the problem? California doesn't need de-icer. Okay, so we don't need de-icer in California because very rarely, not always, but rarely, are we going to need de-icer when it's like over freezing. Minnesota, on the other hand, very cold to check all the time. It's not the same climate. What could I do? I could try some in both places, sort of like with the other ones. If I did half and half in California, half and half in Minnesota, I might have a pretty good idea what's going on, but not so much the way that I'm doing it. So, okay, here's kind of your job in whole again here. On that 12-1 note sheet, that book part was at the bottom. Now, over here, you've got these last 8 questions on here that you're going to need to get onto a paper as well. So let me get this back up. These things together, we can get them all in one place that way, will form homework check 14, assignment number 3. Which again, the next homework check will be Wednesday. So you've got some time to work with on this. But again, at least there's not a bunch of number after number and changing. It's just mainly your opinion and using some common sense and logic for this. So that